Welcome everyone to the course Introductory Neuroscience and Neuroinstrumentation. I am Ratin Joshi. I am PhD scholar at BISLab, Department of Electronic System Engineering, Indian Institute of Science. In today's module, we are going to look at the basics of a brain-computer interface and how we are going to perform experiments based on a particular requirement for BCI. This is a four-part module in which in the first part we are going to see the introductions, which includes the flow of brain-computer interfaces and the various clinical or biological applications of brain-computer interface. Furthermore, we are going to discuss about the different stimuli that are being generated. So stimuli is basically a specifically designed system or specifically designed, be it audio or video, in order to get a required response. So your brain responds to a particular event. So stimuli is nothing but a group of event that has been presented in a specific manner. So how we are going to get that particular stimuli, what are the hardware required in order to get that stimuli, how we can tweak the parameters related to be it auditory or visual stimuli. All these things we are going to discuss in that stimuli generation part. Additionally, there are a couple of demonstrations for auditory and visual stimuli which will help you to design any kind of auditory stimuli you want to design. Once the stimuli generation unit is understood, we will shift our focus to experimental setup and biopotential acquisition. So experimental setup is one of the very important aspect of any neuroscience experiment. So basically, how many electrodes you are going to use, where exactly you are going to put your electrodes, at what level or intensity you are going to give your stimuli, what is the rate of stimuli, everything, like check the functionality of the entire system with some known things, compare it, and then there should be a you can give a signal that okay, now we are good to go with the experimentation. So experimentation setup, and finally the biopotential acquisition. Now mostly we are going to record EEG for this course. We are going to discuss about how EEG can be recorded, how it is being processed, and also EEG is very low in magnitude. It's like microvolt, in some tens of microvolt range. So how you are going to exactly get this much small amplitude voltages or this kind of biopotential, that will be covered in the third module. And once we acquire the biopotentials, finally how to process it in order to get a particular response, there is something called event related potential. So how you can extract those event related potentials from this obtained EEG. So all these things will be covered in this particular module. So considering the first introduction submodule, let's see what we will have in this module. So this is basically the outline of the presentation. I have already discussed about auditory stimuli and how we can acquire the biopotential. We will see in the details. In case of auditory stimuli and biopotential signal processing or EEG related signal processing, or even ERP, event related potential related signal processing, we will also demonstrate a few of the concepts, so it would be easy for you to understand as well as implement. So I'll show you one simplified diagram of any kind of brain computer interface system. So be it any application of brain computer interface, this is the basic structure which will be followed. So if you can see this part, this is basically a stimuli generation part or stimuli generation unit. I have shown two of them, two types. This is on this top part, this is auditory stimuli, where two images are there. One is a normal sound image and a human speech image. Both kind of auditory stimuli are used. In some of the cases, when patient is not that much cooperative, in a way patient is not responding, it cannot respond properly, or let's say the worst case, if a patient is in coma, it cannot respond that well to the sound that is being generated by some machines. Mostly this auditory stimulus is used to detect whether you can hear or not, basically for hearing screening, or your till what intensity you can hear. So that will decide your subjective threshold, that okay, we have two subjects, out of which one can hear it, even the lower sound, or at some places this is a check that whether a person can hear completely or not. So that time there is something called tones, clicks, chops. This kind of tones are presented to know a hearing threshold for a particular subject, whereas for a patient who is not completely healthy, or neuro it's neural condition, or like, so he is like kind of as I mentioned, if a person is in coma or something, at that time it is advisable to present human speech sound, be it is of some relatives or some other sound which is very much familiar to that person. So it's like this both kind of pre-recorded stimuli, auditory stimuli, as well as pre-programmed auditory stimuli can be used as a auditory stimuli generation unit. In the same way, there are different kind of visual stimulus. So, and it differs in various attributes, like which kind of shape you are going to use. So some standard visual stimuli has round shape. That's something called blue ball and red ball. So this different events or different stimuli can form the final stimuli, in which this instances, the different images are been ordered in specific manner. Other way, in most of the eye related conditions, or eye related diseases, there is something like you might find character recognition. So this is the kind of customized visual stimuli, as well as there will be a stimuli with different intensity. So same way, like you define a threshold for your auditory screening, you can define a threshold for your vision field. So, and one more prominently used visual stimuli is checkerboard. So checkerboard is nothing like a chessboard, if you have seen. And inverted checkerboard visual stimuli is very, very prominently used in many of the visual evoked potential testings. So once you understood this stimuli generation, I'm talking flow wise. We will go into the detail of stimuli generation, how we can generate and how we can program it. But yeah, for now, once you can understand how stimuli is generated with respect to your particular presented stimuli, your brain responds and some form of potentials getting elicited. So in order to get that biopotentials, you need electrodes. So here in this image, a proper setup, proper EEG cap is shown with electrode placed on it. All these electrode will be recordings will be given to your signal conditioning circuits. So I already mentioned that being in very low in magnitude, it's very critical to obtain all this EEG biopotentials. So that is done with some smartly designed electronics consisting of combinations of filters, amplifiers, and mainly instrumentation amplifier. And finally, you are going to process it. So in order to process it in your computer, be it MATLAB based signal processing or any other process, Python based processing, you are going to convert it into a digital form before transmitting. So mainly this biopotential acquisition consisting of instrumentation amplifier, your filters, your filters, it will be having both kind of filters, band pass and band reject. I'll tell you why. So mostly in this experiment happens in specifically allotted room, but there also there is a high chances of getting power line interferences. So in order to remove this, we are going to use, there is something called band stop or notch filter with respect to your power line frequency 50 hertz. So it will have instrumentation amplifier, it will have your filters, both kind of filter, band pass, band reject. It will have a broadband amplifier, and finally it will have ADC, multi-channel ADC, in order to convert the obtained analog value into digitalized form. Once you convert it into digitalized form, you have many wireless transmission protocol. Mostly in today's practice, BLE, that's Bluetooth Low Energy modules, or there's something called RF This kind of modules are used to transmit the obtained biopotential, and it has been like most of the modules are have kind of, you can receive the data with using dongle into your laptop. So further you can process it using any of your software. So this is a basic flow for brain computer interfaces. So we will check each module in detail. So before checking each module in detail, I have listed down some of the top key points in each module. So we'll see each and every key point one by one. So I have already discussed about auditory visual stimulus, but there are some parameters. With respect to that, we can change the particular response, and there are some biopotentials that responds to a change in your one of the parameter. Basically they are being generated with auditory change. So this auditory change can be characterized by frequency, it can be characterized by duration, it can be characterized by the presentation stimuli rate, it can be characterized by a timbre. A timbre is nothing but if you play a particular chord in your guitar, and if you play the same chord in your keyboard, you will get a different sound. If you play B sharp in guitar and B sharp in keyboard, you will get a different sound. So that is what timbre is. Okay, so this kind of specifically designed or customized auditory stimuli can be used. Also, in both the cases, auditory and visual, it's very important that we can find exactly how many number of events are used. So in most of the cases, as I mentioned, it responds to the auditory change. So we should have a multiple auditory stimuli in a proper sequence. So before starting an experiment, you should have a clear idea how many number of events you are going to use, be it auditory or stimuli. One more type of evoke potential is somatosensory evoke potential, where auditory and visual, both potentials are localized at your ear and your eye, obviously, but somatosensory is global. It is related to your sensations. So if somebody touches you, you will clearly get a sensation. So it is like a global evoke potentials. Further, we will have a look at experimental setup. So before starting any experiment, you should know that where you are going to put your electrodes, right? How you are going to record it. Before that, is there any requirement or any change that needs to be done for a particular subject? Which kind of electrode you are going to use? If it is dry electrode, fine. If it is wet electrode, how you are going to prepare the skin for that? Okay, each and every person has a different kind of head with a different density of hairs. So which kind of electrode? There are different type of electrode. I'll show it to you. There is something called a flat electrode. There is something called spike electrode. There is something called comb electrode. So which kind of electrode you are going to use? Where you are going to place it? And all this thing should be finalized before starting any experiment. So first you should know the site of electrode, where you are going to put your electrode on your head. You should also know the montage. Now, montage is a way to acquire different biopotential based on your electrode. So if you directly put the recordings from your electrode, it is like you are taking a monopolar value of that. Now if you refer particular value to some other electrode, it's called a reference montage. And why this referencing and all is required is because if you take any nearby electrode as a reference, most of the common noise will get eliminated. We will see this thing into the detail. I will also show you an example of same recording done for two different montages. Okay, we'll see that. And I already mentioned that for wet electrode you need to prepare your screen. So generally when a subject comes, you have to, it depends from where you are going to take your recording. So you have to wipe it up with spirit, and then there are some specifically available paste or creams which is being used. So that will like when you perform an experiment, that will make sure that you will get a best response with your electrode. Be it mostly in case of wet electrode, the screen preparation and all will be required. Further, if we move ahead, there are few things which we must take care. First and foremost, the biggest problem for any biopotential acquisition in open environment would be your power line interferences. So you should be using a shielding. Now how to use, and exactly which kind of shielding we should use, how it can be used, and how it stops your electromagnetic interference, we will see. Also, it has been recorded, observed many times in case of multi-electrode placed on your skin or scalp. One of the electrode might get little bit disturbed, or that electrode's recording will not come properly. So always make sure before you start an experiment that all electrodes are properly connected to the scalp. Very important point. One more thing, your particular device will have several subunits. Like your acquisition unit will have one function to do, your stimuli generation will have one function to do. All the subunits must have a common ground. Also, we will see when I will show you one example. This is a mixed signal electronic design. So it will be having analog as well as digital ground. So both the ground should be separated and kept at a proper place. So all this thing will come into a picture when you design electronic circuit or PCB in order to make your EEG acquisition, or let's say EEG ERP extraction system. And also it is advisable to check your stimulus functionality. We'll talk about more in the upcoming slides. So, and first, finally, you should have, if you are performing any experiment, this involves EEG involves the human subject, so you must have an ethical clearance of performing any kind of experiment. At the same time, if you are performing this experiment in any of your subject, be it anyone, even if it is your friend or anyone, you should be having a proper consent form signed by a subject. Now, some of the cognitive neuroscience experiment involves newborns or neonates. So in that case, you should have a parent's consent or guardian's consent. So ethical clearance and patient consent or subject consent or any of the guardian's concerns are two of the very essential step for a research methodology. You must have this thing before you start your experiment. So we'll see which kind of biopotential we are going to acquire, but we will also see which kind of electrodes we are going to use. So this is nothing but a patch electrode. Some of you might have seen it in ECG recording. It will be placed on your chest and ECG will be recorded. So this is patch electrode. Additionally, mostly for EEG signals, we are using nowadays we are using dry electrode, but it is smaller than this. So it will be something like this. I already mentioned that you have to gently wipe with your forehead or wherever you want to put your electrode with spirit, and then you can apply one gel that will kind of make sure that your skin impedance will match with the it will lower down your skin impedance, and then further you will use one adhesive gel which you are going to put it inside your adhesive conductive gel, which you are going to put it inside your wet electrode. Wet electrode is shown here. So this is a kind of a wet electrode with kit in order to perform any kind of experiment. Further, we will see the dry electrode. So the dry electrode, two kind of dry electrode are shown. This is when your person is too hairy, it is difficult to get recordings with flat electrodes. In that case, we are use this kind of spike or comb electrodes. So finally, this is the this is the site which will come into the contact of scalp, and from here we are going to acquire the biopotential. These are two views, front views and back views. So this will be the summation of all these small spikes which is acquiring this biopotential, whereas this is kind of comfortable electrodes in case of if a person is not too hairy, or you are going to record your biopotential from your forehead. If you are going to make any kind of headband or something, if you are going to put your electrodes on your forehead, I think dry electrode would be a great option. But yeah, if you are going to measure it in someone who is very hairy, and if you want to take a recording from your forehead, it's good if you can go with spike electrodes or comb electrodes. So once you get that, these are the very basic step in order to get your final, in order to extract your ERP. So what are the steps? First is whatever you have, biopotential and stimulus or event, both should be inserted to your system on which you are going to process it. Further, there are some pre-processing algorithms available to remove some kind of artifacts. Now, if you record EEG, if you have seen or come across any kind of EEG recording, even a small movement of yours can clearly disturb your EEG. You can clearly find out that if a person is moving, you can see in your EEG. If a person can even blink, you can you properly see that kind of shape in EEG. If a person is even kind of swallowing something, or if a person is moving his eyes, you can easily see this kind of things in your EEG. But the problem is that while taking a recording, if a person even blink or something, it will be a part of recording. So in that case, what we can do is, before performing some subsequent operation, we should be able to remove all these artifacts. So like there are two kind of artifacts. One is getting generated by human subject. As I mentioned, all these eye blinks, eye movements, some muscle movements, those result in EMG. And other type of artifact is artifact which has been generated by the other interference environment. As I mentioned, electromagnetic interference. Then it is highly possible that if you are not shielded wire, or your wires are too nearby without shielded, then there will be some interference or crosstalk between the wires and all. So all this thing will result in unwanted signals in your EEG, and all this thing will be removed by pre-processing algorithm. So once you pre-process it, once you remove the noise maximally, whatever noise you can remove, you have to do filtering. So filtering, basically in most of the EEG analysis, we don't want any component above 70 hertz. Even in some of the experiment, people used to take 1 to 30 hertz or 0.5 to 30 hertz. So these are the basic range for any brainwave or EEG processing. So then you can filter it. Also, as I mentioned, you would have used notch filter or band stop filter in order to combat the power line interference. If you want, you can again use one notch filter for safety purpose in your software part as well. If you are not using it in your electronics or in your hardware, generally all modern day EEG acquisition device has this option of keeping notch on for both the frequency, 50 hertz and 60 hertz. So in Asian countries 50 hertz, if you go to US and all, it's 60 hertz. So both the notch frequency band stop filters are available in any EEG acquisition system in current day. But yeah, you can still, if you want, you can put one more layer of safety by implementing it into your software or in MATLAB. So, and then further, this EEG's range, as I mentioned, EEG is in the few tens of microvolt. So even after pre-processing, there are some values which will go beyond plus or minus, let's say 150 microvolts or plus or minus 100 microvolts. So based on your application, you can set this artifact rejection criteria. So the values greater than 20 or plus or minus values greater than plus or minus 100 or plus or minus 150, you can remove and replace it with baseline. Baseline is nothing but your normal ongoing EEG, which is in the very smaller amplitude and without any kind of too much activity or too much higher amplitude and all. So it is basically an average value of ongoing EEG. That's baseline. So you can get rid of this kind of artifact, and there is a provision to mention this kind of range. So this way you can reject the artifact. Further very important step is epoch generation. Now I have already mentioned that due to variabilities of EEG potentials, we need to give a particular stimulus or set of stimulus multiple times to record the event, and finally we'll average it. Now how many times you are going to repeat this thing? Let's say you are going to repeat this thing for 100 times. So to get that 100 different time intervals from the obtained run of EEG is nothing but your epoch generation. If your same kind of stimulus is presented 100 times and your one stimulus time interval is 1 second, then your entire experiment duration 100 seconds, and from the recording of 100 seconds you are extracting 1 second for 1000 times. That is nothing but your epoch generation. Bin creation, bin operation, we will see in signal processing module. It would be little difficult for you to understand from now. So when I discuss about multi-event stimuli, 2-event and 3-event stimuli, it would be very easy after that how you can operate through the bins and why bins are required first of all and what we are doing, and finally you can plot your final outcomes. There are ways to plot EEG. You can plot it as a function of your head also. Head location, like there are some landmarks in your head, so wherever there is some more activity you can show it in different color. That's one thing. Other thing, you can show your standard error of means, because we are considering almost 120 epochs in some of the experiment, then you should show like this is the average value, but what is the deviation in simpler terms, more simpler terms, standard deviation, or how it is going up and down from the averaged value. All these things are very important if I talk about the signal processing aspects of EEG recording system. So this would be the final very detailed view of any brainwave recording system or any brain computer interface system. We'll quickly look at the applications, and after that we can jump into the specific module. So what are the basic applications? This is just to give you a motivation that what you can do if you can record the EEG. Okay, so all this let's say sensory systems, like be it a vision or hearing or anything, that will be processed in your brain, in the cortex. There is a visual cortex, there is a auditory cortex. So there the entire flow of your sound perception or your vision perception finishes. So by recording EEG in a proper manner, you can give an impression that okay, this guy can hear it properly, this person's vision is at this stage, currently at this level, and this person is has some issue. You can make a screening tool for hearing and vision. At the same time, if a person is suffering from deafness or blindness, you can even quantify the progression of the disease using EEG. Yes, there are few experimental protocols and stimuli generation practice which you need to follow. But once you know that, you should be able to at least screen a particular subject or patient for hearing screening. Further, there is few more brain related diseases, epilepsy. So if you have a EEG waveform, there are some standard chunks of EEG which can be used as a biomarker for epilepsy. Now, epilepsy is very dangerous disease, because sometimes in like patient or subject can even lost complete control of his body. So you can, if you can record EEG, if you can record EEG properly, you can even make a tool or screening tool which can record the EEG and tell that, okay, this guy has more activities compared to normal subject. So hearing screening, vision screening, epilepsy screening are kind of, uh, very straightforward applications of brain computer interface. And further, if I go ahead, there is something called brain functionality. So your brain has the different functions to do, like sensing perception, auditory perception, visual perception, memorizing stuff, so, and character recognition, many things are there. So uh, if you can make some combined stimulus which we can, using which we can elicitate this, all this kind of brain waves, and from brain wave you can tell that, okay, this guy's brain works, or this part of brain or this particular type of stimulus getting recognized by this guy very well. So it's a kind of a quantitative measure, or result of your brain functionality, or index of your brain functionality. So this is also one of the possible application of brain computer interface. There are several disorders. Alzheimer's is there, schizophrenia, autism, then ADHD, depression, anxiety. All these things can be quantified or captured with some modification. Obviously there will be disease or application specification, application specified changes which you have to do. But this is kind of, all these clinical applications of BCI system. If I talk about some other applications, so this is a very nice review on IEEE biomedical engineering. If you see this thing, it has shown that we will only focus on this EEG. If you go intracranially, then you can record ECOG also, electrocorticograph, but we will be focused on EEG. It will get digitized, and then feature extraction and algorithm and all. What it can do, if you follow this same, it is somewhat exactly similar kind of structure or flow which I have mentioned. What you can do is, you can based on your brain waves or your thinking, you can perform environment control. If you think it like, I would like to turn on the fan, it is possible from your brain signals. You have to train your this thing network and all, but you can do that. You can control the movement. If you want to make some kind of robotic arm or something, you can do that. You can use it for locomotion, as well as you can use it for neurohabilitation. So all these applications is possible if you use this if you use this BCI interface, brain computer interface. So I hope you got some basic idea about how BCI is performed, or at least the flow is clear now. In the next sub module, we will see how to generate a particular auditory stimuli, which kind of auditory stimuli are there, how it looks like, and how to generate it, using which hardware to generate, and how we can alter the different parameters of auditory as well as visual stimuli. I hope this introduction part is clear. We will meet in the next lecture to discuss stimuli generation in detail. Till then, you take care.